Find the angle between the factor 3i minus 4k and 2i plus 3j minus 6k. So to answer the number I, we have factors 3i minus 4k. This is, I call it factor A. And then I have another factor B, 2i plus 3j minus 6k. To find the angle between two factors, we can use scalar product. So A dot B equals to magnitude A times magnitude B cos theta. We can rearrange this into cos theta equals to A dot B over magnitude A magnitude B. So A is 3, 0, minus 4. We have 3i, 0j, and minus 4k. Dot B, 2, 3, minus 6 over magnitude A is 5 and magnitude B is 4 plus 3. 4 plus 9 is 13. So 7. So this is equals to 6 plus 0 plus 24 over 35. So cos theta will be equals to 30 over 35. So theta will be cos inverse 30 over 35. So this is equals to 31.0 degree. That's for I. The factor of A has magnitude of 15 units and is in the same direction as the factor 3i minus 4k. Factor OB has magnitude of 14 units and is in the same direction as the factor 2i plus 3j minus 6k. Express OA and OB in terms ijk. So we have to find the factor OA in the direction of 3i minus 4k with the length of 15. So in here, we have to find the magnitude of the factor A, and we can find the unit factor. So factor A, before, the unit factor of A is 1 over magnitude A times factor A. So this is 1 over 5 times 3, 0, negative 4. This is A. So unit factor is a factor that has length of 1. And we know that this factor has length of 5. Magnitude A equals to 5. So that means OA has magnitude 15. So we can find factor OA by using the magnitude times the unit factor in the direction of A. So 15 times 1 over 5, 3 over minus 4, so equals to 9 over negative 12. So it's 9i minus 12k. This is OA. Yeah, because OA, this is OA, has magnitude of 15 in the direction of factor 3i minus 4k. So I can find the factor 3i minus 4k. So we know that this is 5. So that means OA will be equals to 3 times of vector A. So we can see that here OA is 9i minus 12k. A is 3i minus 4k, so it's 3 times. Now, to find the factor for the given magnitude, we can use the unit factor. So multiply the magnitude and the unit factor. So we can apply it the same to B. So the magnitude of B is 14, and the unit factor of B is 1 over magnitude B is 7, and the factor B is 2, 3 minus 6. So that means OB will be equals to 14 times 1 over 7 to 3 minus 6. So this is twice here, 4, 6 minus 12. So OB will be equals to 4i plus 6j minus 12k. That's II. And triple I, find the unit vector in the direction of AB. So vector AB is vector AO plus OB. So AO is negative 9, 0, 12. Yeah, AO is the opposite of OA. Yeah? So we can just put negative of this plus OB. OB is 4, 6, negative 12. So this equals to negative 5, 6, 0. And the unit factor of AB will be 1 over magnitude AB. It's 5 squared plus 6 squared times negative 5, 6, 0. So 1 over 25 plus 36. So 61. So this is the answer. Two, relative to an origin, the position vector of points A and B are, so this will be the position vector of A, and this will be position vector of B. Find the value of P, which OA and OB are perpendicular. If two vectors are perpendicular, we can use the properties of A dot B equals to 0. So A is 2, 1, 2, dot B 3 minus 2P equals to 0. So this is equals to 6 minus 2 plus 2P equals to 0. 4 plus 2P equals to 0. So P equals to negative 2. II. In the case where P equals to 6, use the scalar product to find the angle AOB. So angle AOB. So I can draw it. This is A, this is O, this is B. So angle AOB is here. So that means we have to find OA and OB. So OA is A. So 2, 1, 2. OB is B, position factor B, 3, negative 2, and then P is 6. And then to find the angle, so we can just use the scalar product OA dot OB equals to magnitude OA, magnitude OB, cos theta. So cos theta equals to OA dot OB over magnitude OA, magnitude OB. So that means it's 212 dot 3 minus 26 over the magnitude of OA is 3 and magnitude of OB is 9 plus 4 plus 36, 7. So equals to 6 minus 2 plus 12 over 21. So equals to 16 over 21. This is cos theta. So theta is cos inverse of 16 over 21. So equals to 40.4 degree. And for the III, express vector AB in terms of P, and hence find the values of P for which the line of AB is 3.5 units. So vector AB is B minus A. So that means this 3, 2 minus 2P minus A, 2, 1, 2. So equals to 1 minus 2 minus 1 is minus 3, and P minus 2. This is vector AB, and then the length of AB, so magnitude AB, is equals to 3.5. So using the Pythagoras, 1 square plus minus 3 square plus P minus 2 square equals to 3.5. So that means 10 plus P, we expand, yeah, P square minus 4P plus 4 equals to 3.5 square. It's 12 over 12.25. So we can simplify P square minus 4P, and then 14 minus answer equals to 7 over 4. So plus 7 over 4 equals to 0. I can multiply by 4, so 4P square minus 16P plus 7 equals to 0. So I can factorize 2P, 2P, and then 7, 1, minus, minus 14 minus 2 minus 16P. So that means P equals to half, or P equals to 7 over 2. Number 3, relative to an origin O, the position vector of point A and B are, so this is A, position vector A, this is position vector B. Find the value of OA, OB, and hence state the angle OA, whether AOB is acute or right angle. This one should be dot here. So that means OA dot OB will be equals to 2 negative 84 dot 7 to negative 1. So equals to 14 minus 16 minus 4. So this will equals 2 minus 6. And then we want to know is the angle AOB is acute, obtuse, or right angle. So from the scalar product, we have cos theta equals to OA dot OB over magnitude OA and magnitude OB. So OA dot OB is negative 6 divided by magnitude OA. Magnitude OA will be positive, and magnitude OB as well will be positive. So that means the cos theta will have the negative value. So cos of negative value, cos inverse of negative value will be in the second quadrant. So it will be obtuse. The result will be obtuse because cos negative in the second quadrant. That's for I, and for the II, the point x is such that ax equals to 2 over 5ab. Find the unit vector in the direction of x. So we have to find the vector of x. So vector of x is OA plus AX. We can construct this here, OA plus AX. So the start should be O and the end should be X. So in the middle, it can be anything as long as they are the same. So OA is 2 minus 8, 4 plus AX. What is AX? AX is 2 over 5 AB. And what is AB? So we have 2 negative 8, 4 plus 2 over 5. AB is B minus A. So it's B 7, 2 negative 1 minus 2 negative 8, 4. So this will equals to 2 negative 8, 4 plus 2 over 5. 7 minus 2 is 5. 2 minus negative 8 is 10. Negative 1, negative 4 is negative 5. So that means 2 negative 8, 4 plus 2, 4 negative 2. So that means this is equals to 4, negative 4, and 2. And then we can find the magnitude of OX. Square root of 4 squared plus minus 4 squared plus 2 squared equals to 16 plus 16, 32, 36. So equals to 6. So that means the position, the unit vector in the direction of OX is equals to 1 over 6, 4, negative 4, 2. That's it. Number 4. The diagram shows the pyramid OABC with its horizontal base OAB, where OA is 6, 8, and angle will be 90 degrees. The point C vertically above O and OC is 10. Unit vectors I, J, K are parallel OA, OB, and OC as shown. Use calculator to find angle ACB. So angle ACB is here. So we have to find CA, and we have to find CB. So CA. So what is the coordinates of A, B, and C? So the coordinates of A is in the x-axis. So it should be 6, 0 in Y, and 0 in Z. B will be in Y-axis, 8, so 0, 8, 0. C will be 10 in Z, so it will be 0, 0, 10. So CA will be A minus C, coordinate A minus coordinate C. Coordinate is equals to the position vector. So A minus C, so A will be 6, 0, 0 minus C 0, 0, 10. So equals to 6, 0, negative 10. This is CA. And CB will be B minus C. So this will be equals to B 0, 8, 0 minus 0, 0, 10. So 0, 8 minus 10. That's CB. Now, to find the angle ACB, so that means cos theta will be equals to CA dot CB over magnitude CA, magnitude CB. So CA is 6, 0, negative 10, dot CB 0, 8, negative 10 over magnitude CA is 36 plus 100. So root of 136 and magnitude of CB is root of 164. So the cos theta will equals to 6 times 0 is 0 plus 0 plus 100 over root of 136, 164. So that means the theta will be the cos inverse of 100 divided by root of 136 times 164. So it's 47.96 or 48.0 degree. Five. The diagram shows the triangle OAB in which the position vector of OA and B with respect to O are given by C is the point on OA such that OC equals to P times OA, where P is constant. Find angle AOB. So AOB. So this one. So we have to find OA and OB. Okay, we have OA 2, 1, minus 3. OB negative 3, 2, negative 4. So angle AOB is cos theta OA dot OB magnitude OA dot times magnitude OB. So equals to 2, 1, negative 3 dot negative 3 to negative 4. This one is 4 plus 1 plus 9. So root of 14. And this one, 9 plus 4 plus 16, root of 29. So cos theta will be equals to negative 6 plus 2 plus 12 over root 14, root 29. So the theta will be negative 6 plus 2 is negative 4 plus 12. So it's 8 over root of 14 times root of 29. And then cos inverse. So 66.6 degree. For II, find BC in terms of P and vector ijk. So we can find BC from BA plus AC, or we can use BO plus OC. BO is negative OB, and OC is POA. So that means OC is P times OA. So we put the number negative minus 3, 2, minus 4 plus P 2, 1, negative 3. So that means this will be 3 negative 2, 4 plus 2p, p minus 3p. So BC will be 3 plus 2p minus 2 plus p, 4 minus 3p. So in IJK, it's 3 plus 2pi plus minus 2 plus pj and plus 4 minus 3pk. That's II. And for the triple I, find the value of P given that BC is perpendicular to OA. So perpendicular means BC dot OA will be equals to 0. So 3 plus 2P minus 2 plus P, 4 minus 3P dot OA 2, 1, negative 3 should be equal to 0. So that means 6 plus 4P minus 2 plus P minus 12 plus 9p equals to 0. So we can simplify. 6 minus 2 is 4. 4 minus 12 is negative 8. 4 plus 1 is 5. 5 plus 9 is 14. So plus 14p equals to 0. So 14p equals to 8. So p equals to 8 over 14. Or divided by 2, 4 over 7.